Hi, hello. Thanks for having me too. It's really a pleasure to be here. I feel like I'm a little bit out of place just because dealing with a scale of architecture in terms of the disciplinary framework and a computation seems to be always the after effect of the computation itself. It's really great to see Andrew and his work and having him end on a nostalgic note again. This talk is slightly out of my space of comfort as well, so bear with me a little bit. I was really excited when Daniel asked me to participate in the exhibit, and I was kind of trying to figure out how this can be, to some degree, a reflection of a crisis of consciousness I've been having recently, being an architect in a world of computing and trying to solve the problems which are relatively pragmatic, and sort of moving within a model of determinacy, in using the computation as a problem-solving method, especially within a context of Carnegie Mellon, which in terms of understanding of a building science and a model of architecture as a performative system has been quite deterministic. So I'm going to talk about the three pieces which are actually in a gallery currently, and which all three of them came out of a body of work which I've been working on for quite a while. I look at them as a sort of a set of three set of objects which come from the singular code. However, they're incredibly different. And as computation is typically kind of a prompt to the illusion of determinacy, this set plays with the indeterminate expression of a singular computational code. And however, the three objects originate from the same base code, they manifest a variety of differentiated gestural and behavioral effects. I'm really interested in a kind of a biological model of architecture, the architecture as a reactive form, where the model for computing within this space is really to kind of computing on the invisible, and in that response to designing the visible. This is a Matthew Piper picture, photo of a tree, and really looking at a kind of from a point of view of genotypical and phenotypical feedback, where my work has been kind of rooted in use of simulation in the early stages of design as a predictive model. Away from optimization routines, the goal of looking at the cues within a computational method is really understanding behavior and performance patterns specific to, let's say, in this case, thermodynamic routines. So, for example, simulating the convection delays in a building components actuated by geometric manipulation of a surface geometry, start determining the formal responses to the architectural design. On the other side, then a kind of a large scale of the use of large scale of urban data and GIS, which comes from sort of a geospatial information sets and physical simulation frameworks that to a large degree, all this work embodies the historical tension between deterministic and stochastic use of code, as you all saw in the exhibit, which Daniel so brilliantly curated. I actually missed the opening, and I went there on my own a few days ago, and so I had time to actually read through the whole curation, and it sort of the realization came upon me that the attempt of codifying the design process, which comes from Chuck Eastman's attempt to replace the architectural drawing by numerical description in a code, has been in a direct ideological tension with Steiny's work on shape grammar as a visual pattern language as an open-ended design process. And I feel like that this certain framework also with the ideology of architectural design within a different kind of ecology of a school of thinking, has been really captured by even within my own process. So, back to the project itself. So we started looking a while back at a water behavior within a built environment, and The attempt was to describe the effect of a topographical flow-based system as a dynamic water flow that responds to changes in urban morphology, topographic manipulation, building placement, right? So it was kind of a problem-solving idea of how we can understand pragmatically through a use of computation the topographical water flow on a terrain. However, this turned into the kind of expanded exploration of a series of non-deterministic effect, where in this case, the piece which has been generated from a random topographical surface called flow duration is a time-based exploration of a spatialized measured flow pattern. Is this working? Slowly. It's essentially a description of a topography in reverse. It's a description of a topography where through the three-dimensional subdivision, mesh subdivision routine, you're looking at a kind of indexing of the topographical expression within a two-dimensional projection while capturing the kind of a time factor within this drawing. So it's a color coding according to the sequence and numerical value of each curve. It creates its own kind of aesthetic and informational uncertainty, and it becomes sort of a numerical description of a topography itself. The idea for this piece, which has been translated in a lenticular print, which you may have seen in the gallery, was not to create a kind of a rational description of a topography, but really through the printed layers, which force you to position your body within a space, able to read the drawing, to kind of look at the spatialized effect of the drawing itself by code. And so kind of reversing the idea of visibility and invisibility to look at the piece as a kind of a reactive space. The same project same code was kind of used and expanded to create a landscape flow, which we actually did last summer with a couple of my former students as a competition, which is a project which explores a land building and urbanization strategy inspired by natural sedimentation process. So kind of expanding on idea of the flow and a mesh subdivision routine to a recursive method of changing of the points of a surface into as a kind of a downhill interpolation. It looks at the new land formation combined with large-scale industrial rigging structures to perpetuate the sedimentation process and to kind of help to understand how the territory can be expanded within the extreme weather events. In a gallery, the final image is really more framed as a painterly set. And so looking at it as an objectified set of data through the lens of line, scale, color, layering. So it's a kind of a look at the, in addition, even though this project has a kind of a deep computational analytical value and a geographical accuracy embedded in the code, it really becomes a detailed portrait of a landscape and using kind of a reversal and a variation within its own aesthetical determination. The last of the three projects, it's a Sentient Object, which I just realized yesterday it's not working at all in the gallery itself. It's going back to the notion of a sentiency as a kind of a tactility of a reactive architecture. And a division between humans and looking at a kind of a division between humans and their environment while using physical simulation of the surface as a agent to index, in this case, a temperature differences. So this is a project we're working currently on. We're looking at the interaction in between a kind of material form and human biofeedback while using human physiology and emotiveness as an activation of a change in material character. And using thermochromics and embedded electromechanical controls, we can change the surrounding thermal and microclimate and surface tactility and its thermal expression. We want to consider this system kind of holistically as a collective biological matrix that engages new forms of communication, feedback, moving away from computing the form as an analytical feedback, rather to fully embed and distribute it, the computation within the matter itself, where the sensory feedback and effects are kind of reflected directly in the object itself. Thank you.